Welcome back, engineering design students. Today we are going to be talking about potentiometers. So to get the party started, we're going to look back at our fading LED with analog output. So this is the last project we did where if I hit start simulation, an LED gets brighter and dimmer because of the length of time that the voltage is on. And we talked about how the Arduino does not send medium voltage. That's not its job. It can send on and it can send off, on being 5 volts, off being 0 volts. And the way it can simulate a medium voltage is by blinking, is by sending it on for different amounts of time and off for different amounts of time. And that mimics a medium voltage, but doesn't actually give us medium voltage. So what do we do if we want medium voltage? And the answer is a potentiometer. So to find it, I have mine already loaded, but if you just write pot, potentiometer shows up and there it is. Okay, and it has 3 pins, terminal 1, a wiper, and terminal 2, and we're going to talk about what all that stuff means. So first, let's look at what, if you were going to look at a schematic, so that would be a circuit drawn out in symbols, this is what a potentiometer would look like. You'll see either one of these. And the idea is that this arrow kind of can go up and down and change the voltage or change the resistance. Now, this potentiometer is actually a 2-in-1 deal. It can either be a thing called a rheostat, or it can be a voltage divider. So a potentiometer, depending on how you wire it, is 2 things in one. So one thing it can be is this thing called a rheostat. And a rheostat is this. It's a potentiometer that only uses 2 pins. So it would use the far right pin, as in maximum volume, the pin that would be closest to maximum volume, and the center pin. And this pin right here would not be wired. It would just be empty, not used at all. And you use a rheostat if you want to vary current, as in how much current is going through. I don't want to spend a lot of time talking about that. What I do want to spend a lot of time talking about is how a potentiometer works. So how a potentiometer works is the power comes in, or the electricity comes in this side, so that would be connected to the plus, right? So the plus comes in, and then depending on where this thing called the wiper, where that is how far it has to travel around to exit. Because this wiper connects directly to the out. So this pin that is called a wiper on this, right here, this wiper, actually on the inside connects to this knob right there. So the power would go in right here, and it would come out here as the wiper if it is a rheostat, if you're not using this pin. So power goes in here, comes out there, and basically the further that you turn the wiper, the further around it goes, the more resistance it meets. So what is inside of a potentiometer is just a wire that's a resistor. As in, it's a wire that electricity kind of goes through. It's a bit of a grind. It's kind of an uphill battle to get electricity to pass through this. So if you turn the volume up, then there's not much resistance, and almost all of that power is going to go into the wiper and out. But if you turn the volume way down, then the electricity comes in and has to travel through this entire, oh my gosh, it's so hard, before it hits the wiper and goes out. So that's how volume meters, or potentiometers, or volume control knobs work. And if it gets all the way here, then usually it's off, as in there's so much resistance on this loop that electricity won't even enter. It's just not worth it. There's no prize you can dangle. It's just not going to happen. So that is how you would use a potentiometer, as what it really is, if you do it as a rheostat, is a resistor. It's a varying resistor. So when the knob is way over to the right, there is no resistor. The resistor is gone because energy comes in this pin and goes straight into the wiper and straight out, and there'd be no resistance. So that'd be full volume. And as the wiper gets turned, the wiper being this knob right here, right? Right now the wiper is at the lowest setting. As the wiper goes from the highest setting to the lowest setting, what you're really doing is you're changing this resistance from, let's say, 1 to 10 to 100 to 1,000, depending on what the what kind of potentiometer you have. So what a potentiometer, if it's used as a rheostat, is just a variable resistor. You get to choose how much resistance you want right now by moving this knob around and deciding how much of the resistor the electricity has to go through before it enters the wiper and exits. So that is a potentiometer as a rheostat. Now let's see it as a voltage divider. Now a voltage divider means exactly that. It divides the voltage. So again, the power comes in, but there's actually two ways out. One way is at the end, the ground. So this would return back to your battery or back to the ground port. So electricity can flow through this kind of nonstop. And then you have your output, which is, again, you have this resistive strip, you have a resistor here, but some of it will come through the output and some of it will go through the ground, right? So you're varying the voltage that goes through here and here. You're dividing that voltage because there's two outs. So it'll be divided between the out, and this is where you would attach the rest of your circuit to, and the ground. This would go directly to the ground, whatever that is. And that is if you want to vary the voltage. So this is the wiring that we are going to use. We're going to use it as a voltage divider. So we're going to take the right pin, again, if volume were all the way up, that pin, and we're going to attach that to power. And then we're going to take the left pin, as in if the volume were all the way down, the left pin, we're going to attach that to ground. And then we're going to attach this to the LED and see what happens. I don't know. Let's check it out. But the first thing I want to do is I want to take the Arduino out of this. So I'm just going to use the Arduino as a power source. So now I'm going to take the anode and I'm going to direct it to 5-volt power so that even though there is all this code over here telling, the Arduino what to do, we have nothing plugged into port 9. So it's just running code uselessly. And all this is a 5-volt power source straight to the LED. Straight to the LED and then back through. And again, this resistor is just so we don't blow out our LED. That's what I want. Now, so if I, just to show you, what we would have is a constant light, right? And there's the voltage. So the voltage is on. It's giving me 5 volts because this says 10 volts, so 10 volts would be up here. This line, if the line were all the way up here, it would be a 10 volt printout, but it's halfway. So it's halfway between 0, this line, and 10, this line, so it's 5 volts. So we're getting a constant stream of 5 volts to this LED. Well done. Okay, now let's get a potentiometer in there. So I'm going to rotate it a little bit just to make it slightly more visually obvious. Now we talked, so volume, full volume is over here. So right now it's at the lowest setting. So what I would like is I would like the full volume, this pin, to go to power. Oh, but it's off my screen. Helps if you prepare the screen, Jay. No way, really? Okay, there we go. So we've powered our potentiometer, and this one here, that is the low volume, that has to go to ground. So this ground is just closer, so I'll use that, but we could, of course, use these pins down here just as well. And so now the power comes into the potentiometer, it goes around the resistive strip, and it leaves, doing absolutely nothing. Now let's make it do stuff. Let's take this and put it right there. And now the path, just so we can look at this path, the power comes in here. It goes into the potentiometer. It goes through the resistive strip until it hits the wiper, being this line right here. Then it exits and enters the LED and then goes home. So let's see what that looks like. Let's zoom in just a smidge. Clearly I'm not very good at zooming. There we go. Okay, so what do we have here? Well, notice, whoa, 40 microvolts. That's nothing. So even though this looks like a huge amount of power, I know it's not much power because one, the LED is not on, so not even enough power to turn on an LED. And I see that this number here has changed to 40 microvolts. That's super, super small. What happens if I bump this up? Oh, the number changed. Now it's to 1 volt. So this top line, and let me scooch down just a little. This top line means 1 volt. So I'm getting 1 volt coming through here, entering the LED. Now you'll notice that's not much light. All right, 1 volt's not going to do it. So if I go back up to 1 volt, which is right about there, a little over, come on. That's about 1 volt. There you go. Power's coming in. It's going through a resistive strip all the way around. It's entering the wiper and off you go. And by the time it hits the wiper, there's 1 volt of power still left there. It's getting a 1 volt. And what happens if we move it up a bunch? Well, now on a 4 volt scale, it's basically at 4 volts. Again, this is 0 and this is maximum. Whatever number is here would be on this line. So we're getting 4 volts. Hey, and I'm starting to see some light. Sweet. Notice if I turn it down, the light turns off. And if I turn it up, the light gets brighter and brighter. Let's go a little bit further. What does this get us? So way up here, we're still on a 4 volt scale and just a little over 4 volts. That's what, like 4¼ volts, right? And we have a little more light there. And what if we move it up a bunch to maximum? Whoa, maximum. So now the power is coming in and it's immediately entering the wiper and immediately leaving. And I know that it's immediately entering the wiper and immediately leaving because this says that this is now at a 10 volt scale, which means this line right here is 10 volts and it's halfway there. Halfway between 0 and 10, and I don't know much, but I'm pretty sure that that is 5. So now we're getting, that kind of full light, and I can use this to lower, and turn it off, and raise, and raise, and raise. So the difference between the potentiometer and the Arduino dimming this is the potentiometer is actually changing the voltage. We are getting voltage that's in the middle. Like right here, it's 4 volts, right? And if I drop it to here, it's still hanging out around 4 volts. What about down here? What does that give me? Oh, 2 volts. Woohoo! A little over 2, right? Because this is 0. This says 2, which means that this last line on the screen is 2. So it's like 2.5, right? Well, actually, it'd be 2.25 if you want to do the math right. This would be 1, that would be 2, and it's a little higher than 2. So I'm getting higher than 2 volts, a little higher than 2 volts with a potentiometer. But just to really send this home, if I delete the potentiometer and I connect this back to 9, this only feeds out 5 and 0 volts. Again, the Arduino only has 2 settings, off and on, and it is passing through, the LED is passing through the same brightnesses that we were seeing with the potentiometer, but it is doing it through mimicry, as in it is actually going completely on or completely off for different amounts of time, which is not the same as the potentiometer. The potentiometer was actually changing the volts, so it was getting brighter and darker due to the amount of volts passing through it. So your homework tonight is, I would love to see an RGB LED. Look at that guy. Imagine if we took one of these and we attached a potentiometer to each pin. So we'd have one potentiometer attached right here. We'd have another potentiometer attached right here. And we'd have a third potentiometer attached right here. And then by varying the 3 dials, I would be able to make any color possible. Give it a little more red, give it a little less blue, all that kind of stuff. Now, do you need an Arduino for this? No, not at all. Right? You could totally use a coin battery to power this. So you could make this entire thing using a coin battery, 3 potentiometers, and an RGB. And again, I recommend using a 220 resistor just so this doesn't blow up. But it doesn't actually blow up because it's a simulator. So if you don't use the 220 resistor, I won't cry. So using just these 4 things and a resistor. All right, I guess I should probably be a completist and put a resistor out there too. Using just these 5 things, 1, 2, 3, 4, 5, and well, if I learn how to count, it'd be 6. 6 items right here. You should be able to make this this bulb be any color by just adjusting the red, blue, and green values for it. That is your homework. Send me a screenshot of the circuit and kind of a fun color. So just choose one color that uses at least 2 of these potentiometers so I can make sure they're actually working. And give me a screenshot of that and you get full credit. So that's all I got for you. Good luck.